In UniFi network settings for networks, if you create a new VLAN, you have the option of choosing the gateway as the router, which is default, or you can choose your layer 3 switches. If you choose different routers, you may see different options in the detailed setup. So in this video, let's go through all the differences, trying to understand what's the technical reason that lead to the differences and how they are implemented differently if you choose gateway or L3 switch as the router. Okay, let's get started. In my lab environment, I use UDM Pro as the gateway. I have two L3 switches, the USW Pro 24 and US XG6 PoE. I'm going to use the gateway and the two switches, create multiple VLANs, then we can dig deeper to understand the different settings. Okay, I have created three VLANs. VLAN 10 has the gateway as the router. VLAN 20 uses USW Pro 24 as router. VLAN 30 uses US XG6 PoE switch. Okay, now let's start the comparisons. The right side, VLAN 10, left side, VLAN 20. Let's start from the very first difference. For VLAN 10, which is using the gateway as the router, you can see it has the zone selection, and by default it's internal. Left side, for VLAN 20, it uses L3 switch. You can see it doesn't have a zone selection. So let's try to understand the differences from the zone-based firewall perspective. Some people may say, what's the point talking about this? Zone-based firewall is the functionality of a gateway. If your VLAN is not routed by the gateway, of course, you don't have the selection for zone, right? Yes, that's right, but it doesn't address the real question, which is even if your VLAN is routed by your switch, in some situations, the traffic still needs to be routed by the gateway. Then in that situation, how the zone-based firewall treat the traffic which comes from L3 switch? That's the real question. But the answer is not apparent on the UI because there's no zone option on the UI. That's what we need to discuss. So you can see for VLAN 10, for zone selection, you have three options. Internal, hotspot, which means guest network, or DMZ, right? Let's just use the internal as the setting for VLAN 10. And for VLAN 20, it doesn't tell you which zone the VLAN 20 belongs to, but we can easily find it out. Let me go to the zone-based firewall. Let me enable this block inter-VLAN firewall policy. So you can see this is a super simple custom firewall policy. They simply block any to any as long as source zone is internal and the destination zone is internal, right? And for debugging purpose, I enabled the syslog logging. Then in the upper left terminal, let me SSH to the gateway. Go to syslog folder under var log ulog, then show the file change for syslog emu.log. Okay, then from the lower side terminals, let me show their IP addresses first. From the subnets, you can tell they belong to different VLANs. Then from the middle VLAN 20 virtual machine, let me try to ping the right side VLAN 30 machine. Just ping it once. It's successful. There's no any syslog generated. It makes sense, right? Because we are talking about two VLANs which are both routed by switches, even though they are routed by different L3 switches. The routing still doesn't require gateway. I can prove that in the right side VLAN 30. Let me trace route using the VLAN 20 machine's IP address. By examining the routes, you can see the whole path has nothing to do with the UDM Pro, the gateway. It only needs this switch, another switch, and then the target virtual machine itself. It doesn't involve the gateway's routing. So that's why the firewall is not triggered. The block inter-VLAN custom firewall policy doesn't apply. However, if still from the VLAN 20 machine, but let me ping the left side VLAN 10 machine. See, it's blocked. And from the syslog, we can see the generated logging, right? From the detailed information, you can see it's from LAN to LAN, which confirms the traffic comes from internal. And then the input is the BR4040. If you go to the network setting, you can see it's this inter VLAN routing special VLAN, and this VLAN is managed by the gateway itself. So the input interface is BR4040. The output interface is BR10 because my supposed target is in VLAN 10, right? However, it's considered as inter VLAN, so it's blocked. So go back to the VLAN 10 and the VLAN 20 setting. For VLAN 20, even though it doesn't show the zone selection drop-down box, we already know it belongs to internal. For VLAN 10, you have the luxury to change the zone. For example, you can change it to guest or DMZ, right? For the L3 switch VLAN, you cannot change it. The zone is internal. Okay, that's the difference. And before we move on, let's expand the discussion a little bit. You may think just because of the VLAN 20 and VLAN 30, they are routed by switches. That means in zone-based firewall, you cannot do anything about them, right? It's not really true because as we just discussed, some traffic has to be routed by the gateway, even though they involve VLAN 20 and VLAN 30, right? So for those traffic, you can still do something if you want. Let me show you an example. So in the right side network application, if I go to zone-based firewall and from internal to internal, create a policy, allow VLAN 20 to 10. The source is VLAN 20. Even though here I wish I can select network and directly choose VLAN 20, but as you can see, the system simply doesn't list VLAN 20. Why? Because VLAN 20 is not routed by gateway. But it doesn't matter. I can specify the VLAN 20's subnet here, add. Now I have the source specified. Then for action, I will say allow. Then for destination, I will say internal. So in this way, what I want to achieve is to allow VLAN 20 to talk to VLAN 10 by using zone-based firewall. Add policy. You can see the newly created firewall policy goes after the block inter VLAN, which won't work, right? So we need to reorder it. I need to move the block inter VLAN down, but after this one. See this one? Allow VLAN 20 to 10 return. There's a log sign. It is automatically generated because when we create this allow VLAN 20 to 10 firewall policy, we say automatically allow the return traffic. So this is automatically generated, but because this is also inter VLAN, I need to move this block inter VLAN after it as well. Okay, done. Then in the VLAN 20 machine, let me try the previously failed ping command again. Ping the left side VLAN 10 machine. It's successful. Okay, just want to use this simple example to demonstrate. Don't think zone-based firewall has nothing to do with layer 3 routed VLAN. If you want, you can still do something. Okay, then let's move on. The next difference, internet source IP. So for VLAN 10, you can see this option. Because in this lab environment, I have two WAN ports. For each WAN port, you have a drop box. You can select internet source IP. Let me explain you what this means. In the lower part, UniFi network application, let me show you the primary WAN port setting. So you can see under the IPv4 address, I have this address already, right? Then here, I have additional IP address. For this lab environment, I have totally 2 IP addresses for the same WAN port. In your case, your ISP may give you multiple public IP addresses. You need to make a decision for a given VLAN what IP address you want to use for the outgoing traffic. However, if you check the left side VLAN 20, you don't see this option. So let's dig deeper to see how Ubiquiti supports the right side VLAN 10's internet source IP option and whether we can do the same thing for VLAN 20. For the VLAN 10 primary WAN port, let me change source IP to the second one, .2.203. Apply changes. Then let me launch a Wireshark. I'm going to use SSH remote capture, connect to the UDM Pro. For capture, for interface, I specify any. I want to see all the gateways interfaces traffic. But for remote capture filter, I want to limit the traffic to 8888. Let me start. Whatever you see now, they have nothing to do with my testing because I haven't started yet. However, you can already see all the IP addresses used is the other one, the 202 one, not the one we specified. Why? Because what we specified only applies to VLAN 10. So now in the lower side VLAN 10 machine, let me ping 8888, ping it only once. Okay, it's captured. Let me stop capturing. The traffic starts from here, from my Linux machine. It traveled internally inside gateway. Then it sent out from the one part. See, what's the one part IP address used? It's the .2.203, exactly as we specified. Now you see the effect of this internet source IP customizing, right? Having seen the effect for VLAN 10, you may wonder what IP address will be used by VLAN 20. Let's test it. In Wireshark, let me restart capturing. Then from the VLAN 20 machine, let me ping 8888, ping it once. Okay, captured. Stop capturing. See, starting from this packet. See the third one from .2.202, which is the so-called main IP address for my primary one part, right? This is the default behavior for VLAN 20, which is routed by switch, not by gateway. It only uses the main IP address. In the lower part SSH session, let me show you IP tables, the NAT table only, and the internet source IP we just configured is implemented by using this SNAT. If the out interface is Ethernet 9, which is my primary one part, and if the source network is VLAN 10, it will do what? It will do SNAT. It will change the source to this IP address. This is the IP address we specified on the UI, right? I don't see any reason why the same thing cannot be implemented for those VLANs routed by layer 3 switch. However, if you check the VLAN 20 setting, you don't see the internet source IP configuration. For unknown reason, Ubiquiti doesn't want you to specify it. But what if you really want to achieve the same setting for the layer 3 routed VLAN? How you can do that? Naturally, we can think of creating a SNAT rule, right? Let's do that. In the policy engine, let me go to policy table. Then I go to NAT rules. See, we already have 3 NAT rules. The second and the third one, they are the regular masquerade rules for the 2 one parts, right? But see the first one? What's this? This is the SNAT rule we see in the lower part IP tables. This SNAT rule is the result of what Ubiquiti automatically generated on the UI. This is the exact SNAT rule, right? From the user interface, you can see it's generated by the system, so it's read-only. So what we want to do is we want to create a new one for our VLAN 20. We want to achieve the same effect. Let's see whether we can do that. Create a new policy. It's NAT and it should be source NAT. Let me give it a name. Then it applies to primary one part, no problem. And for translated IP address, I don't want to use this main IP address, right? So let me choose the interface IP. And here I need to select the other one, which is .2.203. Okay. And then for source, see here, I do have the option to choose VLAN 20. So this dropdown works differently in the firewall policy UI, right? I can simply select VLAN 20. That's it. That's how easy this SNAT rule is. Okay, then let me add it. So there's no any error. In the lower part, in the SSH, let me see what's the generated SNAT rules in the IP table. Strangely, I don't see any change. What we generated here, the SNAT, it doesn't show up in the NAT table at all. I believe this is a Ubiquiti bug, so we can validate by using Wireshark. Let me start capturing. Then from the VLAN 20 machine, ping 8888. See, it is still using .2.202. Our SNAT rule doesn't work. I don't want to give up. Let me make a final try. The cause for it's not working is due to Ubiquiti failed to generate the SNAT rule, right? Even though on the UI, we don't see any problem. But in the backend, let me manually generate that SNAT rule. This is the command I'm going to run. I use IP tables. For net table, I specify this chain name, which is what we saw in the IP tables for the existing working SNAT rule for VLAN 10, right? I want to simulate that. I want to manipulate this chain, and the dash capital letter I means I want to insert the new rule in the very beginning. For source, I want to specify the VLAN 20 subnet. For the output interface, I specify the primary one part. And for the target itself, is an SNAT rule. It will translate to this source IP address. Okay, run it. Okay, this dash sign is wrong. Change it, then rerun it. It's successful. Then let me show you the net table again. You see our new SNAT rule, right? It works in the same way as the existing SNAT rule for VLAN 10. Now let me go back to Wireshark to see whether it works. Restart Wireshark capturing. Then from the VLAN 20, run the exact same command again. Okay, see the result? Perfect. The internet source IP now is .2.203, exactly as what I want. Then let me summarize this difference. For some reason, Ubiquiti first doesn't show this internet source IP setting for VLAN 20. That's problem number one. Problem number two, even if I want to create a custom SNAT rule from the UI, everything goes fine. But in the backend, the SNAT rule was not generated. You can see the workaround taken by me was to manually create the IP table rules, right? Of course, it's just for testing purpose. It's not a good way to do it in a, let's say, production environment. I hope Ubiquiti can fix this issue. Okay, let's move on. For VLAN 10, I have the isolate network option. For VLAN 20, I also have this option. However, see the difference in the label. For VLAN 20, it says ACL, and for VLAN 10, it doesn't say that. This is because to achieve isolate network for the gateway routed VLAN, Ubiquiti will use firewall to implement the network isolation. But for the layer 3 switch routed VLAN, Ubiquiti will use ACL to achieve network isolation. So let's see how these two are implemented differently. Let's first check the VLAN 10. Let me enable the isolate network. Okay, it's done because it should be implemented in the firewall. So let me go to the zone-based firewall. From internal to internal, we have a new firewall policy generated. This one, you can see the log sign. This means it's generated by the system. If you click on it, see the details. The source is for VLAN 10 and the action is block and the destination is internal. So just by using this firewall policy, Ubiquiti achieves VLAN 10's network isolation. Let's check for VLAN 20 if we enable the same option for isolate network, apply changes, because the label says ACL, right? So let me go to policy engine. See, for ACL rules, it says 0. There's nothing. So here Ubiquiti doesn't do a good job on the UI to implement things in a consistent way. For automatically generated firewall policy, the system can display it in the right side for VLAN 10, right? But for VLAN 20, even though the system have done something in the backend, it doesn't show anything in the front end. That will only confuse people. So in this video, let me dig deeper SSH to the switch itself and show you how the ACL is implemented. So in the lower part SSH, let me exit UDM Pro, then SSH to the layer 3 switch. Then let me go to CLI mode, EN for enable config. Then let me show you the ACL rules. The command is show IP access lists. you can see 3 different ACL. Each of them has multiple rules. Let's check them one by one. Here you can see all the 3 existing ACLs. They all apply to VLAN 20. That's exactly what we specified. We want to isolate VLAN 20. Check the first one, run the same command, but followed by the ACL name, guest public. It doesn't have any rule. Then try the next one, guest private. It will simply deny the VLAN 20 devices from accessing all the 3 possible private IP address ranges. This makes sense, right? Because we want to isolate the VLAN 20. Then show you the last ACL, which is guest VLAN 20. It permits 2 special IP addresses. So even though the VLAN 20 should be isolated, it doesn't mean it's 100% isolated, because to make it work, the system has to allow some very specific access. For example, access to the VLAN 4040 IP address of this switch so that the routing can work. The other one is to access the gateway IP address. Again, in this case, is one of the IP address for the switch. Just to make sure you follow me about these 2 IP addresses, let me exit the CLI, list the IP address. This IP address is VLAN 4040's IP address for the switch, and this IP address is the gateway IP address for VLAN 20, which is both IP addresses belong to the switch itself. So I believe now we are clear about how the system implement the network isolation differently for the 2 different VLANs. The only thing I hope Ubiquiti can improve is to show the generated ACL in this case. Okay, move on to next difference, allow internet access. See, for VLAN 10, I do have this setting, but for VLAN 20, I don't, right? Let's try to understand it. So for VLAN 10, even though I specified isolate network, I don't really want this VLAN 10 to be 100% isolated, because I still wanted to access internet. So that's why I switched this on. Then to understand how this is implemented, we can go to firewall, from internal to external. You can see by default, it will allow all traffic, right? The system doesn't really need to do anything. It's automatically allowed. However, if I go to VLAN 10, I disable the allow internet access. Then go back to firewall, from internal to external. See, a new rule is generated by the system. If the source is VLAN 10, it will block access to external. Just by manipulating the firewall policies, the system can easily allow or disallow internet access for VLAN 10, which is routed by the gateway. However, for VLAN 20, see, the system doesn't have that option. Because of previous step, we already isolated the network. So let's see at this moment, based on the current setting, whether VLAN 20 can access internet. So from the VLAN 20 machine, simply repeat the ping, right? Because 8888 is on internet. So let me ping it. It is pingable, which means without doing anything, even though the VLAN 20 is isolated, I can still access internet. However, there's no direct setting to disallow internet access. How we can simulate the VLAN 10 setting to forbid VLAN 20 from accessing internet? We can simply define a custom firewall policy. So let me go to zone-based firewall, from internal to external. Let me create a new policy, give it a name. Then for source zone, it's internal. Then I need to specify the subnet for VLAN 20, add. Then I want allow. The destination is external. I don't want to change anything else. Add policy. For action, I need to say block, because we want to block the internet access, right? Apply changes. So in VLAN 20, let me ping 8888 again. See, now it's not possible. So we successfully blocked the internet access. So now it's clear about the difference for VLAN 10 and the VLAN 20 when it comes to internet access, right? Let's move on to the next difference. It's about multicast DNS. So you can see for VLAN 10, you have the checkbox to enable or disable it. For VLAN 20, you can see the option is here, but the checkbox is disabled. It says for layer 3 switch network is not supported. To explain the reason behind this, in the lower part SSH, let me show you the UniFi gateways MDNS related setting. You may know multicast DNS reflector is implemented by using Avahi in UniFi gateway. So let me show you the Avahi configuration. It's under run avahi daemon.config. So the setting is very simple. The part which is related to VLAN 10 is here. Allow interfaces. It has BR0, BR10, which means default network and VLAN 10. Both are routed by the gateway. So now you may understand why for VLAN 20 it cannot be supported. Because in the gateway, there is no interface for VLAN 20. Yes, it does have an interface for the special VLAN 4040, but it doesn't have separate interface for VLAN 20 and VLAN 30. That's why in gateway, the Avahi cannot separate VLAN 20 and VLAN 30. That's why it's not possible to support it in gateway. And then you may know for UniFi layer 3 switch, they run different Linux than the gateway, which means they cannot easily run Avahi. That's why Ubiquiti disabled this MDNS setting. But it doesn't mean it's mission impossible to support MDNS, because you can run a separate Linux machine. And in that Linux machine, you can have dedicated interface for VLAN 20. Right? Then you can simply install Avahi and make the VLAN 20 MDNS working. It should be very straightforward, so we won't cover that in this video. Then move on to the very last difference. For all the settings in this part, they are all related to DHCP. You may know for gateway routed VLAN, the gateway runs DHCP server. So it's very powerful, so it supports a lot of features. But for layer 3 switch routed VLAN, the DHCP server runs on the switch, not the gateway. It has much less feature. That's why all the settings here, they are all disabled. This is a very straightforward difference, but I still want to show you to confirm VLAN 20 device gets IP address from the switch, not the gateway. So in the lower part of the screen, let me run a Wireshark listening on the LAN traffic. Let me start capturing. I already put the display filter to DHCP. Then VLAN 20 machine. Let me go to network, disconnect the wired network, then connect. See right away, you see the two packets captured in Wireshark. The first one was sent from the VLAN 20 machine to the broadcast IP address. Then see the return packet is from this IP address. Remember previously, I already showed you this IP address is from the switch. This is the VLAN 20's gateway IP address. Because the VLAN 20 is routed by the switch, so this IP address belongs to the switch. So the switch replies with the IP address for this VLAN 20 machine, not the gateway. Because of this reason, all these features are disabled. And for L3 switch routed VLAN, for DHCP mode, you can also set it to DHCP relay. I do have a dedicated video about this functionality, so I will not cover it in this video. Okay, thanks for watching.